seemed it would be a good place to start our Numbers and Beyond course with the reason we have the number system that we do have. And in order to understand what makes our number system so perfect for us, you have to see a few other number systems. So we'll start with one of the oldest number systems, the Egyptian number system. And the Egyptian number system looks kind of like this. On the right side, we have numbers that we understand 1, 10, 100, 1,000, so on. And on the left side, we have the Egyptian numbers. So, for example, in Egypt, a 1 just looks kind of like our 1. It's just a line. But then when you get to a 10 is already different. It's a loop. And when you get to 100 is a coil of rope. Rope does not start with a W. And when you get to 1,000, you have a flower. And 100,000, we have a tadpole. And 1,000,000, we have a surprised person. Surprised person. And this is how the Egyptian number system works. You just have these different symbols that each represent a different number value. And something unique about the Egyptian number system that we're not used to is it's non-positional. Meaning, back in Egypt, when they were using this number system, if you were to write the number loop, loop, 1, 1, 1, well, 2 loops is 2 10s, and then 3 1s is 3 1s. So this number would be 23. But also, if I had 1, 2, 3 1s and 2 loops, notice these numbers are backwards, but it's still 2 10s and 3 1s, which is still 23. So this number system is non-positional. But we realize fairly quickly a hole in this. What if you need numbers more than 1,000,000? For example, what if you're talking net worth and you have to acknowledge Jeff Bezos? You have to acknowledge that he is worth much more than 1,000,000. Well, the Egyptian number system only went up to there, so it had a fatal flaw, which made us move on. So we move on to the Babylonian number system. And now the Babylonian number system did something that was very important to the progression of numbers, which is it made a repeating number system. You can go as high as you want with this number system. And it works like this. It has 2 characters, a hound's tooth and an arc strike. And if I have the number 1 hound's tooth, well, one hound's tooth is equal to 1. 1 arc strike is equal to 10. So the number arc strike hound's tooth would be 11. Or arc strike, hound's tooth, hound's tooth. Sorry about the handwriting. When I'm writing in our Arabic numerals, it'll be a lot easier. Is equal to 23. 2 arc strikes and 3 hound's tooths. But you notice pretty quickly, if I'm trying to write the number 1,000,000, or if I'm trying to write the number 10,000, even something smaller like 1,000, I'm going to have a lot of arc strikes. I'm going to have a lot of arc strikes if this is just each one of these is worth 10 and each one of these is worth 1. And the way we fix that is we choose a base for this number system. So this number system is actually, the Babylonian number system was in base 60. And what does that mean? Well, that means you see these arc strikes. I'll change my color. These arc strikes are in front of the hound's tooths, and they mean 10. So this is 2 arc strikes in front of 3 hound's tooths, so it means 20 in front of 3. Well, in the Babylonian number system, in order to move on, you can get all the way up to 1, 2, 3, 4, 5 arc strikes and 9 hound's tooths. 1, 2, 3, 4, 5, 6, 7, 8, 9. Not perfect, but you get the gist of it. Which is the number 59. 59. But this system is in base 60. So what happens when you get up to the number 60? Or what happens when you get up to the number 61? The number 61 is actually just a hound's tooth in front next to another hound's tooth. So the number 61 is 2 hound's teeth next to each other. And the way we denote that they're two different, that it's 61 and not 2, is we put them a little further apart. So this would be the number 61, while this would be the number 2. And you see pretty quickly how confusing this system gets. Not only do we have a positional system where two hounds' teeth that are a little further apart mean something different than two hounds' teeth that are right next to each other, but we also have that if we're going into high numbers, we again end up with a lot of characters. We end up with weird characters. We end up having to translate it from base 60. And once again, this system is a little confusing. So then we settle on our numbers, the numbers that we use today, which are the Hindu Arabics, the Hindu Arabic number system, which is a base 10 system because there are 10 characters here. Starting with the 0, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 characters. Notice 10 is not a character. 10 is not a character. What does 10 mean? Well, when we count from 0 up to 9, then when we get up to 9, we've run out of characters. So we start back with a 1 next to the next number. So we have 10 is equal to a 1 in the tens place and a 0 in the ones place. So we have a base 10 system with 10 different digits. And in our Hindu Arabics, we actually have little representations of the number system, starting with the first system of Hindu Arabic numerals was the naturals, denoted by a capital N, the natural numbers. And the natural numbers are your counting numbers. 1, 2, 3, 4, so on and so forth. Everything starting at 1, working your way up to infinity. And this worked fine with things like counting sheep, counting how many sheep you have, things like keeping track of money. But what happens if you break even? We grew out of this system because we needed to be able to express 0. We needed to be able to include a 0 in our numbers. And 0 has a great history, which we'll probably talk more about later on in our class. You'd be surprised how recently 0 was added to the numbers. Not every number system and not every civilization had a number for 0. The idea of nothing was just denoted by nothing. So out of the natural numbers, we got the whole numbers, W. Whole numbers, which you guessed it, just includes 0, 0, 1, 2, 3, 4, and so on. And so that's not that important. But what happens if you own a business and you need to express debt? You need to express that you gave money for something or that you owe money to someone. And so out of the natural numbers and the whole numbers grew the integers, which is denoted by a capital letter Z. And the integers, I should write it underneath like the rest, the integers look like this. They start at the negatives, -2, -1, 0, 1, 2, onward. We included the integers. And then from there, we of course needed to be able to express halves of something. What happens if you want half of a pizza, or what happens if you want to buy half an acre of land? So we leave the integers and we go even bigger. We end up with the rational numbers, which is denoted by a Q. The rationals. And the rationals include all numbers where you can have n over d for d not equal to 0, and n is inside of, this little symbol means is inside of, n is an integer. N and d are integers, so we'll put a little d next to the n. N and d are integers, and d can't equal 0, so our rational numbers are anything where this can be true. For example, what if we have the number 12 over 6? What does that mean? Well, 12 over 6 we know is equal to 2, which represents how much each person gets. I like to think of these in terms of pizza, the rational numbers. So if you have 12 slices of pizza, this is the number of things you have. and this is the number of people on the bottom. Well, if you have 12 slices of pizza and 6 people, each person gets 2 slices. How much each person gets? And so that helps explain to us that if we have 0 things and 6 people, well, how many slices of pizza does each person get? They just get 0. They get no pizza. So nobody gets any. Nobody gets any in this case. And even better, it helps to explain that really confusing topic of 6 over 0. In this case, we have 6 things, but we have 0 people. We have 6 things, 0 people. So how many does each person get is not really a question that makes sense. So we say that the answer to this is actually undefined. Undefined. In this case, nobody is home to eat any pizza. Nobody is home. And that's our rational numbers. Our rational numbers is anything that can be represented as 2 integers, one over the other, where the thing in the denominator, the thing in the bottom, is not equal to 0. Because if it is, we have a certain number of things for 0 people. The things don't get used. And then our last piece of our number system conversation, we needed to add in rational numbers. We needed to add in things like this, or with the real numbers, because in this case we only have rationals. We have all the numbers that can be represented as a fraction, but as a fraction of 2 integers. But the real numbers include things like this. Include things like the square root of 2. And the square root of 2 is equal to something that cannot be written as a fraction. It cannot be written as a fraction of two integers. So, starting back at the top, we started with our natural numbers, which were our counting numbers. And then we got the whole numbers. Well, the whole numbers were just equal to the natural numbers plus 0. So our whole numbers were a little bigger. Then we added in our integers. So our integers, or our z, if you remember, that was the letter we went with. Our z was just equal to our whole numbers plus the set of negative whole numbers. Anything that was negative included. And then our rational numbers, you saw my example up here. 12 over 6 was my example. Well, 12 over 6 is equal to 2, so the rational numbers included all of these integers. Our rational numbers was equal to all of the integers, but we add in the fractions, anything like a over b. And then moving on to our real numbers is just the rationals, plus anything that's not rational, or the irrational numbers, things that are not rational. So each number system was a subset of a bigger one and a bigger one until we got to the ones that we like, the ones that we live in most often, which are the real numbers. And the real numbers that we use are the Hindu-Arabic base 10 numbers, because all the other number systems just came up short.